Hello, my name is Jillian Sugard, and today I'm going to talk to you about solving word problems. We're going to go step by step through a systematic way to solve word problems, a sort of map to take you from the problem all the way down to the destination of the solution. And the great thing is you can use this map and apply it to every word problem that we encounter throughout the semester. It's 4 steps that can be applied to every problem. Because as you know, word problems can be very hefty and intimidating, and if we have a systematic way in which to deal with them, it sort of takes that intimidation factor out of it a little bit. So let's get started and explore these 4 steps to solving word problems. So let's talk about the map. When we solve any word problem this semester, I am going to give you a 4-step map that you can literally apply to any word problem. Label, translate, solve, and answer. And today we're going to work our way through each of these steps. Step 1 is to label, and I'm briefly going to talk about what that means, and then we'll go into more depth in a moment. So first, read the problem 3 times. The first time, just read it. The second time, circle words and start writing symbols that you know. And the third time, really focus on what is the problem asking me. The biggest part of this step is to start thinking about your variable. And as you're going to see, we only want to label one variable to solve for in our problems. We are going to want to give it a name, x, y, and know what that variable is standing for. Remember, a variable is an unknown. So there's going to be some unknown in our problem that we need to solve for. Step 2 is to translate, and that's when we're going to take our English sentences to math expressions, equations, and formulas. You can think of math as a language, and just like for any other language, like translating from English to Spanish or English to French, we need to translate from English to the language of mathematics. During this step, you can draw a picture if it helps. You'll find that that will be helpful when you do problems that involve areas or velocities. And take your time to really think it through. The translation step, I think, is one of the hardest steps, but it is also the key to unlocking the rest of that problem. If you translate well, you will do well with the rest of the problem. Step 3 is to solve. And this, I think, is the best step because you're going to take what we've been learning in class, the algebra of it, and use those same concepts to factor and solve. Step 4 is when we write our answer, but the most important part of step 4 is going back to the original problem and thinking about how your answer relates in context to that problem. You want to make sure that you answer in English with units. So if this problem is an area problem, for example, and you're talking about the length and width in feet, you want to make sure that your answer uses the units feet. And again, you always want to go back and think about what your answer means in the context of the problem. Ask yourself, are there extra solutions that the algebra led me to that don't make sense? Do I need to plug my solution back into an equation from step 2 to get additional information? And always be asking, does my answer make sense? And again, as we move through each of these steps, you're going to see what I mean by all of it. So here's our problem. The sum of a number and its square is 72. Find all possible numbers for which this is true. Now, in this first unit, we're going to be looking at 3 different types of word problems. The problem we're working on today is what I refer to as a number relationships problem, meaning we are typically looking for 2 numbers, and we're trying to figure out the relationship, which usually means the operation, addition, subtraction, multiplication, raising to a power. What operation are we trying to use between these 2 numbers? What is the relationship? Remember, we need to have pairs of numbers as our answer. We're looking for 2 numbers, which means we're looking for pairs. Step 1, label. This is the first step in our map to solving these problems. So what does it mean to label? Well, The first thing you're going to do is, like I said, read the problem 3 times. The first time, you're going to just read it. The second time, you're going to circle important words and write important symbols. So when we read this problem, the word sum should pop right out. And this is an opportunity for you to just sort of start thinking about what that means. I might circle that word, I might put a plus sign above it, just to get my brain going. I see the word square. I know that the word square means I'm taking some number and I'm squaring it. So again, I might circle that number. I might write number squared, x squared, something above it, just to get my brain thinking about these concepts. I also might circle 72. That seems to be important here. Now I need to think, I'm going to read that problem a third time, and this time I'm going to think, what is this problem asking me, right? I need to find all possible numbers for which this is true. So I'm being asked to find numbers. And remember, this is a number relationships problem, so we're probably looking for pairs of numbers. I want to then label my variable. I'm looking for numbers, right? So I need to choose a variable name for those numbers. We want one variable, and that is incredibly important. When you solve, you want to be factoring and solving for one variable. Give it a name. Let's call our first number by the variable name x. So we have now labeled our variable. Now we can move into step 2, which is the translation step, which is, in my opinion, the most important step. If you translate well, the rest of your problem will be very easy. You can think of this as the key to unlocking the door to the rest of the problem. So what are we doing in this step? Well, we're taking our English sentences and translating them into math. And you can also use your handy dandy translation sheet that you were provided in class to sort of help you piece through these different words and what they mean in the language of mathematics. So we are taking English sentences to math equations and even expressions or formulas. Always start with what you know. That could mean drawing a picture, or it could mean beginning with real number examples if you find that helpful. For a number relationships problem, remember we're looking for pairs of numbers and the operation and relationship that they have in common. So when I'm dealing with this type of problem, I like to start with real number examples. I know real numbers, 1, 2, 3, 4, 5, 6, and I know how to perform operations on them, multiply, add, subtract, divide. So I like to start with real number examples, find a pattern, and then generalize. Let me show you what I mean. We are dealing with a number and its square. Let's translate that from those English words to math. Well, let's start with a number. How about number 1? Okay, if I start with the number 1, what is its square? Well, 1 squared. The number 1, its square, 1 squared. Let's look at number 2. My number is 2, so its square must be 2 squared. Okay, I'm starting to see a pattern. Let's look at number 3. My number is 3, its square is 3 squared. I'm starting to see this pattern now of how to take my number and its square. Well, what did we label our variable in the first step? We labeled it x. Our first number was x. So if our number is x, then its square must be x squared. I have now translated that phrase, a number and its square, to math, x and x squared. My first number we called x, so my second number must be x squared. There's my pair of numbers. Now I'm going to deal with that entire sentence. The sum of a number and its square is 72. And when I read that sentence, 2 main phrases sort of pop out at me that I can translate here. First of all, the word sum. Sum implies addition. And if you didn't know that, you could look on your translation sheet, find the word sum, and you would see that it comes under the operation of addition. Right? When we add 2 things together, the answer is the sum. The second thing that pops out at me in that sentence is 72. Whenever you see the word is and a number, that implies equality. So the sum of a number and its square is 72, which means our number x and its square, when we add them together, is going to equal 72. And when we translate that, this is the beautiful math equation that we get. X plus x squared equals 72. A number and its square added together is going to equal 72. And now we should be really happy because we have landed on a beautiful mathematical equation that we translated from English words to this mathematical equation. We can use algebra to solve this, which leads us to our next step. Our third step is to solve. This is, in my opinion, the best step because we take exactly what we've been learning in class and apply those algebraic concepts to solving our new polynomial equation. So, in our translation stage, we got x plus x squared equals 72. We can solve this. We can use algebra to solve it. The first thing I'm going to do is put my terms in descending order, which means I want my variable with the highest degree to come first, and then my variable with the next highest degree, and so forth and so on. I want this to be in the form of ax squared plus bx plus c. When I'm solving, I need to get 0 on one side, so I'm going to move that 72 over. Now I have x squared plus x minus 72 equals 0. Why did I do that? Because I want to be able to factor and solve using the principle of zero products. I can only do that if I have my polynomial sit equal to 0. I'm going to look for a GCF. There is none, so I'm going to count the number of terms. I have 1, 2, 3 terms, which means I'm going to use the AC method. Let's fast forward. We've used the AC method. This is how it would factor. Quantity x plus 9 times quantity x minus 8 equals 0. I can use the principle of zero products to solve. If I have two factors being multiplied together to equal 0, well then one of those factors must be 0. So let's look at our first factor, x plus 9 equaling 0. In that case, x would have to be negative 9. In our second case, we have quantity x minus 8 equaling 0, our second factor. If that were the case, x would have to be 8, which leaves us with the solution that x equals negative 9 and 8. So we arrived at two solutions when we solved this algebraically. Okay, so we finally arrived at step 4, the answer. This step is incredibly important because at this step, you need to go back and really think about whether or not your answer that you arrived at in step 3 makes sense in context of the problem. By this point, you're probably a little fatigued. Your brain's been doing a lot of thinking, and you're probably a little mentally tired. So that's why it's extra important to make sure you go back and interpret your answer. And how do you do that? Well, you want to go back to the original problem, which we have here in green, and ask yourself, what was this question asking me, and how does my answer make sense in context of this question? So remember, we were being asked to find all numbers that the sum of the number and its square equaled 72. Well, if you look at the solution we got, x equals negative 9 and 8, some alarm bells should sort of be going off in your head because negative 9 squared doesn't equal 8. 8 squared doesn't equal 9. And if we add negative 9 and 8 together, we certainly get nowhere near 72. Well, did we do something wrong? No, not at all. But this is why it's so important to go back and think about the question so that you can interpret your answer well. We needed a number and its square. And if you remember, we labeled our variable, our number x, and its square, x squared. Well, what did we solve for here, guys? We solved just for x, which means we haven't found our x squareds yet. But we have x, so we can find x squared. Let's start with x equals negative 9. If x equaled negative 9, well, its square would be 81, right? X squared equals 81. So now we have a number x and its square 81. And I just want to take one quick moment and note that when you have a negative that you're plugging in for your variable x and then squaring, you want to make sure that you square the entire quantity, negative 9. Okay, that's important. So now we have our first pair of numbers, negative 9 and 81, x and x squared. Let's look at our second number, x equaled 8. If we square it, we get 64. So now we have our number, x equals 8, and its square, x squared equals 64. So we wound up with two pairs of numbers. Well, what did we have to know about these two pairs of numbers? That they added together to equal 72. So we need to check and make sure that that is indeed true. Does x plus x squared equal 72? Let's look. Our first pair of numbers, x was -9, x squared was 81. If we add them together, we do indeed get 72, so that checks out. Let's check our second pair of numbers, x plus x squared, 8 plus 64, that does indeed equal 72. So these pairs of numbers check. Now, I want you to get into the habit of always asking yourself at this step, what units do I need? For a number relationships problem, we don't really need any units, but as you do other types of problems that involve lengths and widths or velocities, you're going to need to factor in the units like inches, centimeters, seconds, minutes, whatever it is you're looking for. Get in the habit now so that it's always part of your process. We don't need units for this question, so the last thing that we need to do is to mark our answer clearly. I like to write my answers in an English sentence. The number for which this is true, the numbers for which this is true are -9 and 81 and 8 and 64. Notice how I made it really clear that my pairs of numbers were together by using parentheses, so you can clearly see my first pair of numbers and clearly see my second pair of numbers, and then go ahead and circle it for me so it's extra clear as to what your answer is. So what did we learn today? Well, we learned something pretty awesome. There is a systematic way that we can solve any and all word problems that we will encounter this semester, and we have laid out a beautiful map for ourselves that will take us from our first read through of the word problem to our solution. What is that map? Well, it involves 4 steps. The first of which is labeling a variable and only one variable. The second is to translate from the English language to the language of mathematics by taking our English sentences and turning them into mathematical expressions, equations, and formulas. The third is to solve whatever we translated by using algebra. And the fourth is to give an answer with units if necessary, always making sure that in this step we go back to the original problem and see how our solution makes sense in context of what we were being asked, right? We might have to do a little bit more work when we get to our answer to make it make sense. So when you do word problems, guys, always remember that your mindset is just so powerful. If you have a growth mindset, a positive mindset, you will do better. You will learn more. You will enjoy the challenge of a word problem. Embrace it. Say to yourself, I am going to learn and I am going to grow when you start these problems. And I want you to know that you are going to have to practice many word problems to get good at them. It's not going to be just 1 or 2 or 3 or 4 and you've got it down. You have to practice and practice and practice and practice. So I encourage you to enjoy the challenge and to keep practicing until you feel like you've got it. Thanks so much, you guys, and have fun doing your word problems.